All right, 1.8 absolute value. Equations and inequalities. So we're going to start out with the equations. So they're just something equal to. So 10, we've got the absolute value of 4x plus 2 is equal to 5. So when we have absolute value, how many equations do we have? 2. So 1 is copied exactly, so 4x plus 2 equals 5. The other one, we change what it's equal to the opposite sign, so 4x plus 2 equals negative 5. And then I just solve it. So this is going to be 4x is equal to 3, so x is equal to 3/4. And then the other one, 4x is equal to negative 7, so x is equal to negative 7/4. Now, as far as I'm concerned, if you left it like that, that's fine as long as you show both answers. But the way that the book is going to write the answers is the way that it was in the top row of your notes, where it's a solution set of negative 7/4 and 3/4.
What are we having test on this? Or a quiz?
We're having a quiz on 1.6 to 1.8 on Wednesday next week, I think.
Oh, alright.
Something like that. Because I'm not going to give it to you on Tuesday because we have a long weekend.
Oh, yeah.
So it'll be Wednesday. So y'all basically have today and tomorrow for this section, but we'll finish all the examples today. All right, another one. 18, the absolute value of 2x plus 3 over 3x minus 4 is equal to 1. So even though it's got a fraction, we still do the same thing. So it's going to be 2x plus 3 over 3x minus 4 is equal to 1. And then set it equal to negative 1. So 2x plus 3 over 3x minus 4 equals negative 1. So then we multiply this 3x minus 4 by the 1 on this side. So we'll have 2x plus 3 is equal to, since it's just times 1, it's just going to be 3x minus 4. And then now just solve it like a normal equation. So I'm going to move the 3x to the left, 3 to the right. So negative x is equal to negative 7. So x is equal to 7. And then on the other side, I just need to change the signs of these when I multiply it. So I have 2x plus 3 is equal to negative 3x plus 4. So then I've got 5x is equal to 1. So x is equal to 1/5. So my solution set officially would be 1/5 and 7. Are we okay with the equality ones? All right, then let's look at some inequality ones. So process is basically the same. The only other thing that we do differently is when we have the one that we're setting equal to like the negative value or where we're changing the sign of it, we flip the inequality. So 28, we've got the absolute value of 3x minus 4 is less than 2. So we have 3x minus 4 is less than 2 is the first one. Then the other one, when we change the sign, we need to flip the inequality. So it's going to be 3x minus 4 is greater than negative 2. Okay, because it's kind of like the rule of if you like multiply or divide by a negative, that's kind of what's happening with why we change the inequality. And then solve like normal. So 3x is less than 6. X is less than 2. And obviously the rule would still apply if we had divided by a negative. We would be flipping the inequality like normal. So then over here, 3x is greater than 2. So x is greater than 2/3. So now I have that x is greater than 2/3, but I also have that x is less than 2. Okay, so these have to be written a certain way. So this is going to be like case 2 in your notes. Okay, so I could write this in inequality notation as 2/3 is less than x is less than 2. Or I can write it the way that, does it specify? It says give the solution set in interval notation, so that's going to be the parentheses because it's just less than, so 2/3 to 2. If it was or equal to, then it would be brackets. But since it's just less than, it's parentheses. Um, 34. 5 times the absolute value of x plus 1 is greater than 10. So a lot of people, when we get to this point, decide that they're going to write 5 times x plus 1 is greater than 10 and 5 times x plus 1 is less than negative 10. But that's not true. Okay, we can't do that. We've got to move things over before we do the splitting it up into the, or like, well, it's not really splitting it up, before we write it twice. We need to get, so it's just the absolute value on one side. So I'm going to divide by 5. So I'm going to have the absolute value of x plus 1 is greater than 2. And then now I can do x plus 1 is greater than 2, or I can have x plus 1 is less than negative 2. So x is greater than 1, and then over here, x is less than negative 3. So x is less than negative 3, but x is also greater than 1, which means I can't be in between them, so I've got to be outside of them.
We draw that line thing.
Yeah, basically. So essentially what I have is that x is, let me do it this way so it's in the right colors. X is less than negative 3, or x is greater than 1. So this one, the way we write our notation is going to be negative infinity to negative 3. I'm assuming you're talking about a number line.
Yeah.
Which I could do that too. If it helps you visualize it, I would say do it. So, union 1 to infinity. So this is the x is less than negative 3, and this is the x is greater than 1. We're just not the stuff in between, so we're unioning these two things together. All right. These next ones say to solve the equation or the inequality, just because it's a section of them being mixed. The stuff we've done at this point has said like one or the other specifically. So the absolute value of 8 minus 3x outside the absolute value minus 3 is equal to negative 2. So I'm going to say it again because every year this is a problem. People decide that they're going to go ahead and set this up as exactly equal to negative 2 and then the stuff on the left equal to positive 2. But you can't do that yet. We've got to get that absolute value by itself. So I'm going to move the 3 over. So I have the absolute value of 8 minus 3x is equal to 1. And then now I can split it up to have 8 minus 3x is equal to 1. Or 8 minus 3x is equal to negative 1. So then negative 3x is equal to negative 7. So x is equal to 7 over 3. On the other side, negative 3x is equal to negative 9. Divide by negative 3, so x is equal to 3. So again, these are equalities, so this is just a solution set. So this is the little curly brackets and 7 over 3 and 3. All right, just one more, unless y'all feel like you need to see more. So 64, the absolute value of 3x plus 2 is less than or equal to 0. Any ideas what I need to do with this one?
Do the same. 3x plus 2 is less than or equal to 0. X plus 2 is greater than or equal to 0.
So is 0 positive or negative?
It's nothing.
So I only need to do it once.
Oh.
Because it's going to end up basically giving me the exact same thing.
Oh, yeah, you're right.
So 3x plus 2 is less than or equal to 0. So then 3x is less than or equal to negative 2. So x is less than or equal to negative 2/3. And so then that's going to be from negative infinity to negative 2/3. And because it is or equal to, it's going to be a bracket which says that we include negative 2/3. So the only time we can do that is when there's a 0 on the right side.
Wait, why is there a bracket?
Because it's less than or equal to. So if it has the or equal to, there would be a bracket. If it's just less than or just greater than, it's parentheses. All right, then your problems are 17, 33, 37, 49, and 55.